Okay, this is the lesson for 11.3, day 1. The first thing I'd like you to do is this first slide just has some multiplication and division of fractions, just a review of something you've done before. So what I'd like you to do is push pause and work through these. Okay, on the next slide I have your answers. Now I may have done it a little differently than you did, but I kind of wanted to show you this again so that when I get to the more difficult problems, you'll see that I haven't really changed anything that we've done so far. So over here, I took the 2, and then I took the 6 and put it into prime factors. That's what I did here, and the 3 times the 5. And what you can do is just cancel your common factors and see what's left. This is very similar to what we did in 11.2. So I have 2 times 2, that's 4, and 5 left over here. Across the top here, I have 5 times 3. I took the 12 and divided that up into 2 times 2 times 3, and then I actually need another 2 over here. So this is going to become not 4, 5 over 8. Because what will happen there is the 3's will cancel, and we'll have 2 times 2 times 2. Again, here I did something very similar. When you divide, you're left with a 1, so it's not over 0, it's over 1. So I have 8 over 1, which simplifies to 8. Remember when you divide fractions, you multiply by the reciprocal? In this one, I didn't have anything to cancel, so I just multiplied what was left on the top and the bottom. Again, I multiplied by the reciprocal here. No, you can cancel. Another way without doing the prime factors is to do it this way. 9 and 3, I could divide them both by 3, a common factor. Multiply across the top and the bottom. Similar idea here. 5 and 10 have a common factor of 5, so divide them both by 5. Multiply across the top and the bottom. So then we're going to go to these problems, and these ones actually are very similar to what you did in chapter 9. So again, I would like you to try these on your own, multiple ways to work these out. There's multiple ways to do it. I'm going to show you a couple when I go through the answers, but what I would like you to do is push pause and work through these 4 problems now. Okay. Now, you'll see what I did. Again, I did it a couple different ways just to show you. So this piece here, what I did there is I took the 12x and divided it into its prime factors. This is the 20x into its prime factors. There's the 15 in its prime factors. And here's the 18 with its prime factors. And then in green, you can see I canceled out, canceling common factors, because anything divided by itself is 1. So what I had left over after I canceled out was I had a 2, an x, another 2, and an x. So I wrote everything I had left over here. In the denominator, all I had was 3 times 3, so that gave me 8x squared over 9. In the next problem, I did a different, it's really the same idea, I just showed the work differently. I first divided the 6 and the 8 by 2, so that's where the 3 and the 4 came from. X divided by x is 1, so those canceled out. 10 divided by 5 and 5 divided by 5, I divided both of those by 5, and the y's canceled out. So I multiplied what was left on the top, multiplied what was left on the bottom, got 6 over 4, that simplifies to 3 over 2. Now, a third way I could see a lot of you doing this is multiplying across the top. That would give you 60xy. Multiplying across the bottom, that would give you 40xy. Looking for a greatest common factor of the numerator and denominator, dividing both by that, and you'll still end up with 3 over 2. So the blue and the red and the green are 3 different ways. They all get to the right answer. It's just what works for you, what makes sense for you and helps you. Okay, so down here, again, I did the canceling here. I canceled the 7 and the 21. I divided both of those by 7. And the 5 and the 25, I both divided by 5. The A's canceled and the B's canceled. Over here is where I did the prime factoring. So here's my 30m right here. This is my 52m, because remember I had to flip this. My 13t in the denominator and my 15t. I wrote what I had left and multiplied that out to get 8m squared over t squared. Now, in the next set of problems, this looks a little different. You should see that this has addition and subtraction, where the previous ones did not have addition and subtraction. So you're going to you may want to put up your little, we talked about the force fields, the parentheses, to keep you from starting to cancel. Anytime you see addition and subtraction, you should not start by canceling. You got some work to do. All right, so what I'd like you to do is you're going to factor each part out, each of these parentheses out. I know these ones you're right, they do not factor into binomials, but they do have greatest common factors. So take a greatest common factor out of here, out of here, out of here, and out of here, and then see if you can cancel anything. Then I'd like you to do the same thing over in this one. It's the same idea. Look for greatest common factors and look to cancel. So I'd like you to push pause again. So again, 2x plus 4 will turn into 2x plus 2, and then you keep going. Okay, and then I would do the 3. So work through that, push pause, work through that, come back and check your answers. Okay, over here you'll see I did those. So the 2x plus 4 is here. The 3x minus 9 is here. I factored a 6 out of here, and then I just took the 6 and factored into 2 times 3. A lot of you aren't going to have to do that, but I don't know if that helps some of you to break it into its primes. And 5x plus 10 I factored out of 5. I then went through slowly. I said, okay, here's a 2. Do I have any 2 factors on the bottom? Nope. I have an x plus 2. Is there a factor of x plus 2 on the bottom? Yes. So I canceled it. Here's another 2. I already know there's no factors of 2 on the bottom. Here's a factor of 3. Is there a factor of 3 on the bottom? Yes. So they cancel out. And I have an x plus 4, but no other x plus 4s. So I wrote what I had left. I had the 2, another 2, and an x plus 4. And then on the bottom denominator, I had a 5 and an x minus 3. And again, I would leave this factored out. If you distribute it, you're not wrong. It's just that, especially when you get into the higher level maths where you're going to look at more of these in different ways, especially in graphing, it's going to be easier if they're factored out. Over here, I factored out the 6. I factored out the 3. In this, I factored out a 5. I factored out a 4. I looked for common factors, multiplied what was left, and simplified the fraction. In this one, again, there's that addition and subtraction. So whenever you see that, you may want to put those parentheses to, again, keep yourself from starting to cancel. You cannot cancel terms. Anytime there's addition or subtraction, there's terms. Okay, so you may want to put those around. Now, this one here is a difference of 2 squares. We really need to get better at noticing when it's a difference of 2 squares. 4u squared is a perfect square. 4 is a perfect square. U squared is a perfect square. 1 is a perfect square. If it's the difference, has to be subtraction, of perfect squares, then you can factor it. You also need to start looking for a greatest common factor. Now, this numerator does not have a greatest common factor, but this denominator does. Okay, and actually so does this numerator. So I'm going to work through the answers, but if you'd like to try it, you could pause and try and work through. So 4u squared minus 1 becomes 2u plus 1, 2u minus 1. If you multiply those out, you'll get 4u squared minus 1 back. Then in this denominator, I factored out the greatest common factor of u. That's what I did here, and I was left with u squared minus 16. That's right here. But then I said, wait, u squared minus 16, I can factor that even more, and I broke that up into u plus 4, u minus 4. In the top numerator, the right side numerator, I factored out a u, because they both had a factor of u, and I had 2u minus 1 at the bottom. Then again, 2u plus 1, no, I didn't have any of those. 2u minus 1, yep, those canceled. The u's canceled, and the u plus 4 and the other u plus 4 canceled. So this is what I was left with. Over here, again, I was left with a difference of 2 squares, so that factors into c plus d, c minus d. Again, 2 perfect squares, subtraction, you need to be picking this up, that these always can be factored. I took the 4c and broke it into its factors of 2 times 2 times c. There was no addition or subtraction there. That's why I went into breaking this one up. 6c cubed, again, I broke that into its prime factors. And c plus d, quantity squared, please don't say that's c squared plus d squared. It's not. If you don't believe me, come see me. I'll show you why it's not. You can even multiply it out. It's not. C plus d, quantity squared. Whenever you're squaring something, you multiply it by itself. So I just wrote it as c plus d times c plus d. I canceled the common factors, and this is what I was left with. Okay, so go back to any part you need. You can come in and ask me questions if you need. And that concludes 11.3, day 1.